Last video we learned that when direct substitution gives us 0 over 0, this becomes an indeterminate form, and at these times we factor our expression, and when we factor our expression we find the most simplified version of it, and then we just plugged in our regular value and find the answer. But now this was all old news. Now we're gonna see if the question has a square root on it, like root x or root x minus 5 or something like that. If the expression has roots in it and the factoring is not obvious, then we do something called the conjugate method. Before we even move on to that kind of a method, I'm gonna ask you guys, what is a conjugate? Obviously it's a rhetorical question, but conjugate is something which is like the opposite of something. In other words, it means changing the sign between two terms. For example, if I ask you what's the conjugate of x plus 2, then you're just simply gonna say it's x minus 2. And if it was x minus 2, then it's gonna be x plus 2. If we look at it in terms of roots, we can just simply say that the conjugate of root x minus 3 is just simply root x plus 3. I just flipped this minus sign into a plus sign, and nothing new. Similarly, if I ask you what is the root x plus 5 plus 4, you can see the two terms, root x plus 5 and the second term being 4. You just flip the sign and write everything as the same, like root x plus 5 minus 4. Simple concept, nothing rocket science in this one. Now, how are we going to use this conjugate? For that, I would just want you guys to look at the screen and follow along with this example, because that's how we're going to solve this one. It's better to show you rather than telling you in abstract words. Well, in this one, we'll follow the same rules that we first plug in 9 in this, and then we notice as soon as I put 9, I get root 9 minus 3, 9 minus 9, which then turns into 3 minus 3 over 9 minus 9, which is 0 over 0, and this is an indeterminate form. So now what do? We try factorizing, but in this kind of question there is no obvious factorization involved. So we're going to apply the conjugate method. What you guys will do, you first write down the expression as it is, root x minus 3 over x minus 9. X minus 9. Now multiply this whole thing with the conjugate. So if it's root x minus 3, it's going to be root x plus 3. And whatever you do on the top, you do on the bottom. It's the basic math rule, which says whatever happens on the left should happen on the right. Whatever happens on the bottom should happen on the top. So following that same ideology, I do this. Then I notice if I multiply this, I get root x minus 3 multiplied by root x plus 3. And in the bottom, I get the multiplication of x minus 9 with root x plus 3. It might seem a complicated expression, but trust me, it gets simplified in just the next step. How? Because then we see something like this, a minus b multiplied by a plus b. And remember from the previous video, we have learned this is an identity, which indeed turned out to be a squared minus b squared. So then our expression on the top of this expression, the numerator is gonna be root x squared, which is x, and minus 3 squared, which is 9. So it's gonna be simply x minus 9 on top, and in the bottom it's gonna be x minus 9 multiplied by root x plus 3. And now if you could see, the top of x minus 9 cancels the bottom x minus 9, and then you're left with 1 over root x plus 3. Now simply this thing is same as your question. You added nothing here. This thing and this thing are completely same. So now you just simply multiply this thing with the conjugate. So sorry, you don't multiply with the conjugate, sorry, my bad. You just simply put limit x approaches 9 here. Now if I plug in 9 here, I get 1 over root 9 plus 3, which is root 9 becomes 3, and 1 over 3 plus 3 is 6. So in the end, we're left with 1 over 6. If in your first try, if you don't get it, it's all okay, because like this concept has like huge expressions, and sometimes they could just like make the square root scary. But the only thing you should know are the steps. As long as you know steps, you're good, because then you know where to go next. Let's try doing another example, because that's the only way we'll improve. And the ideology is still the same. I first plug in the thing. It's gonna be root 4 plus 5, which is 9, minus 3 over 4 minus 4, and the top becomes 3 minus 3 over 4 minus 4, which is 0 over 0. And we all know this is an indeterminate form. So now we try factorizing, but factorization doesn't work with roots. So we apply the conjugate method. I simply write down the original expression first, root x plus 5 minus 3, x minus 4. Then I multiply this with the conjugate. It's going to be root x plus 5 plus 3. And whatever you do on the top, you need to do on the bottom. It's going to be root x plus 5 plus 3. Now I just simply multiply these two things. I say that the root x plus 5 minus 3 multiplied by root x plus 5 plus 3 over x minus 4 root x plus 5 plus 3. Now, the top one becomes the identity, which I mentioned in the previous question. You could just like come over this a minus b multiplied by a plus b. So the top becomes something root x plus 5 whole square and plus, sorry, it's minus 3 square, and on the bottom it becomes x minus 4 root x plus 5 plus 3. Now if we expand the top, this cancels this, and then we're left with x plus 5 minus 3 square is 9, and the bottom we have x minus 4 multiplying with root x plus 5 plus 3. Now if I further simplify, I start to notice that this thing's top becomes x minus 4 over x minus 4 root x plus 5 plus 3. Now this thing can be simplified easily. How? Because this x minus 4 cancels this x minus 4, and then I'm just simply left with 1 over root x plus 5 plus 3. And now you apply your limits here, because the last expression and the question expression, they're both the same. So then you just put it in this place, and then you just plug it in. It's gonna be what? 4 plus 5 is 9, 1 over root 9 plus 3, which is indeed 1 over 6 again. Now I want you guys to focus on example 3 and try giving the, oh, okay, I made some error in this one. Let me just fix it. Teeny tiny error. Yeah, now I would want you guys to take a look at this question on example 3. It's nothing different. It's the same as example 2, example 1. And yeah, just give it a shot. Pause the video and give it a shot on your own. And then I'll jump on to the next one. The other one is also using the ideology of the conjugate, except now instead of like the root being in the numerator, it's now in the denominator. So if I look closely in this one, I get, first I just plug in 5 directly. I get 5 minus 5 over root 5 plus 4, which is 9, minus 3, and then it's going to be 5 minus 5 is 0, and root 9 is 3, 3 minus 3 is 0, which is an indeterminate form. So now what? Now I just write down the expression first as itself, root x plus 4 minus 3. Now I multiply it with the conjugate on the top and on the bottom. So it's going to be root x plus 4, and then it's going to be plus 3 over root x plus 4 plus 3. And then I would just multiply them. It's going to be x minus 5 root x plus 4 plus 3 on the top, and on the bottom I get root x plus 4 minus 3 multiplied by root x plus 4 plus 3. Now if we look at the bottom becomes the identity, which we learned before. So then we could just simply write x minus 5 over root x plus 4 plus 3. And on the bottom it's an identity, so it's gonna be a square minus b square, which is root x plus 4 square plus, sorry, minus 3 square. Now if you look at the bottom, I'll do all the things on the right side now. This square root cancels the square, and then on the top stays the same first. X minus 5 root x plus 4 plus 3. And in the bottom, now we notice that the square root gets cancelled, so we just have x plus 4. And minus 3 squared is 9, minus 9. So then we notice that the top is still the same, but the bottom becomes x minus 5. Now, the x minus 5 cancels this x minus 5. And then my last expression which I have is root x plus 4 plus 3, and I cannot simplify further. Now, I'm going to put my limit x approaches 5 here again, and plug 5 now. So I notice that 5 plus 4 plus 3. Now, root 5 plus 4 is root 9 plus 3. Root 9 is 3. 3 plus 3, which is 6. And that's our final answer. Now, while doing these kind of questions, obviously you guys will have a time crunch and you will just like try to just do it as fast as possible. So a lot of people forget multiplying. They just multiply the top. They don't multiply the bottom. Or if they're doing the bottom, they forget about the top, because they're just in a rushing moment. So just like on the left, if you see, they multiplied on the top, but there's nothing in the bottom, which is wrong. But you gotta multiply in the top and the bottom. Whatever you introduce, you need to balance it out. That's why. Another one which all obviously happens to me even at this point, like while I was recording this video, while I was practicing, I accidentally forgot to change the sign. Because when you're rushing and when you're just writing it down, it's really easy for you to make this plus minus again. Like, don't even change it. So while solving this, be mindful at least at this step that you gotta change the sign of the original root, because that's what conjugate is. And other than that, I don't think there's any other mistake a person can make. A lot of people do make one more, like the complex expression, like on the top. You see, we don't do anything to it, obviously till the end, because it eventually gets cancelled. So don't try to expand it or do something to it. The only thing you will apply is the identity. This could be in the bottom or in the top, depending on where was the root in the start. So other than that, I don't think there's any other complication in using the conjugate for the solving for these limits. Well, in the next class, I was thinking to just like introduce a new concept. At first I was thinking to just like merge this one, but then I realized that we already know how to use the numbers, like when x approaches 2, 1. But in the next one, I was thinking to just introduce what happens when x approaches to infinity, or it goes to infinity. So we'll learn limits at infinity, and more about, like, we learn about vertical asymptotes in the graph, but now we're gonna learn about horizontal asymptotes. But that's all for the next one. So until then, take care of yourself, like and share it among the friends who need it, and have a good day.